Hi, everyone, and welcome to the fifth and final lesson for this module. And this one's going to be another short one, but it's another one where you're going to need the time to practice. This one is on redox reactions. Now, a redox reaction stands for reduction oxidation reaction. Okay, redox is that like when you take the two things and you shove it together into one name, like Benifer. So redox reactions occur when there is a change in your oxidation numbers. Now, oxidation numbers are different than oxidation states. I'm going to go over the rules for oxidation numbers that was on the presentation page. Remember, oxidation states are the charges. So in a redox reaction, some things are reduced, some things are oxidized, okay? What does that mean? Well, we look at oil rig in order to help us with that. What the heck does oil rig mean? So oxidation is loss, reduction is gain. So here we're talking about oxidation is loss, reduction is gain of electrons. So we're losing and gaining electrons, and that's based off of our oxidation numbers. So redox reactions are with the electrons moving from reactants to products. So all we are going to do currently is to determine if a reaction will be a redox reaction or not. So what we need to do is we need to look at your oxidation numbers, which I said are in that presentation, and I'm going to pull them up here. And we give the oxidation numbers to each specific thing in the chemical reaction, and then we see how do those numbers change from left to right, okay? So here are the rules where I'm going to go through them, but you may need to refer to them just on your own. So rules for oxidation numbers, here they are. So the oxidation number for something in its elemental state is 0. So for example, the oxidation number for iron as a solid or oxygen gas is going to be 0. You see iron or oxygen hanging out by itself, that's its elemental state, and it will have an oxidation number of 0. The oxidation number for a monatomic ion is equal to its charge. For example, the oxidation number for the chloride ion is -1, and for the iron 3 ion, it's +3. Typically, the more electronegative element in a binary compound is assigned the number equal to its charge if it were to be an ion. The oxidation number for fluorine in a compound is always -1, and that has to do with rule number 3. Fluorine is the most electronegative element on the periodic table, and therefore it will always be the most electronegative element in a compound, and that's why it's always -1. Oxygen has an oxidation number of -2 unless it's combined with fluorine, which will be +2, or if it's in a peroxide when it's -1. So of course, there's a general rule, and then there are individual exceptions. Now, oxygen is almost always going to be -2. Just like with hydrogen, it's almost always going to be +1 unless it's a hydride, in which it's the second element in the compound, and then it's going to be -1. In compounds, the elements of group 1, 2, and aluminum have oxidation numbers of +1, +2, and +3 respectively. The sum of an oxidation number of all atoms in a neutral compound is 0. The sum of an oxidation number of all atoms in a polyatomic ion equals the charge of that ion. Okay, so these are the rules. They're here for you. Keep them somewhere close to you because you're going to want to use them as we're going through with this stuff. So let's go back to the notes and let's see here. My first equation, I've got hydrogen gas reacting with fluorine gas to give me 2 moles of hydrogen fluoride gas. Okay, so I'm going to go through and look at the oxidation numbers. The oxidation number for hydrogen is 0. That's its elemental state. For fluorine, it's 0. That's its elemental state. Okay, and I like to write the oxidation numbers above the elements. Okay, so that's 0, that's 0. Now we have HF, and so you have to ask yourself, do I have a rule for hydrogen? Do I have a rule for fluorine? I do have a rule for fluorine. It's always going to be -1. Okay, down below, what I like to do is I like to put the totals. So we don't look at the coefficients for this. I've got 1 fluorine, that's -1. I know that together, these things have to be 0 because it's a neutral compound. That means this has to be +1. There's one of those, so that's +1. Okay, so I've got my my oxidation numbers, and now we see, okay, how have they changed? Hydrogen went from a 0 to a +1. That means that it lost 1 electron. Keep in mind, electrons are negatively charged. Fluorine went from a 0 to a -1. That means it gained 1 electron. Okay, wonderful. Now, we have to say, okay, which ones oxidize, which ones reduce. Hydrogen lost. Oxidation is lost. Hydrogen was oxidized. That means fluorine was reduced. Very simple. That's it. That's literally the extent that we have to do with this. Okay, I'm going to clear this so I can have the space above the next one. Now in the next one, I've got 4 moles of solid aluminum reacting with 3 moles of oxygen gas to give me 2 moles of aluminum oxide. Okay, oxidation number for aluminum, 0, that's its elemental state. For oxygen, 0, that's its elemental state. Now, aluminum oxide. I do know a rule for oxygen. Oxygen is always -2. There are 3 of those oxygens, so overall that gives me a -6. Now I know that this compound has to total 0. So that means this part has to be +6 to cancel out with that -6. Now, if overall it's +6, but there are 2 aluminums, that means each one is +3. And there are my oxidation numbers. Okay, and then we just see how it's changed. Aluminum went from a 0 to a +3, so it lost 3 electrons. Oxygen gained 2 electrons. So aluminum, oxygen. So aluminum lost, oxidation is lost. So this was oxidized, this was reduced. And that's it. That's simply all we're doing with this. Okay. Please keep in mind, only one thing can be oxidized and only one thing can be reduced. If you have only one thing being reduced and then nothing being oxidized, then you've got nothing, then you did something wrong. If you've got 2 things being reduced, then you've done something wrong. So please keep that in mind. Only one thing can be oxidized and one thing can be reduced. Now we're going to do more of these from the homework, but I just want you to notice that on the next page, there are practice. The answers are in the completed notes. And then there's review with nuclear reactions, because technically that's the type of reaction. So make sure you try to do those, check your answers, okay? And I'm going to share my screen with the homework for the redox stuff. So we'll do the first one because here it's A, B, and C. So this is a good practice for everything, where C is talking about the oxidation numbers and seeing if it's reduced or oxidized. And keep in mind, not everything is a redox reaction, okay? Some things will be redox reactions, some things they aren't redox reactions, and that's okay. Not everything is a redox reaction. So we're gonna do question number 1. I'm gonna try to do all 3 parts here for you. I don't know why I said try, I can do all 3 parts. So we'll start by type of reaction. So A, I've got sodium sulfide solution added to zinc nitrate solution. That's a double replacement reaction. Write the balanced chemical reaction. Okay, so sodium sulfide, Na2S. These are aqueous solutions. Zinc nitrate, ZnNO3 2 aqueous, gives me, oh, I have to figure out what they are. Well, it's NaNO3, which I know is aqueous because all nitrates are soluble, plus zinc sulfide, which is ZnS. Okay, so now here, I'm going to pause the share so I can go to the solubility rules and just check this real quick so it doesn't get rid of it. Sulfide ions are insoluble except group 1A. So This is going to be a solid. Okay, balance it. 2 here, and that's it. So that's part B. And C, is this a redox reaction? So in order to determine if it's a redox reaction, we have to see if the oxidation numbers change from the left side to the right side. So there is a rule for sodium. It said group 1, group 2, and aluminum are +1, +2, and +3 respectively. So that's +1. There are 2 of them, so that's +2. That has to be 0. That's -2. Please keep in mind that there are nitrates on both sides, so I can keep this by just doing the oxidation number for the nitrate as its charge. Zinc will be +2. There's 2 of those, so that's -2. That has to be +2 to give me 0. Sodium, well, if this is -1, that has to be +1. And there's not a rule for zinc or sulfur. So the most electronegative element gets its charge, that's -2. That has to be +2 to cancel out. So I've done my oxidation numbers, and you can see here that my oxidation numbers do not change from the left side to the right side. So question number 1, this is not a redox reaction. And that is totally okay. And that's all we're doing with our oxidation numbers. I'm just determining, is it a redox reaction? What's being oxidized? What's being reduced? All right. And that's it for this module. That's all the notes. Take your time now to do the rest of these practice problems, the ones that were in the notes and these ones. Like I said, not hard. You just have to do it. All right. Let me know if you have any questions. Ask them at the end of class or put them in the chat, and I'll see you next time.